Saturn. Its brilliant gold colour and mysterious rings have solidified its status as the jewel of the solar system. Many astronomers have even confessed to entering the field after being enchanted by the planet's beauty. You only need to see it once to understand the obsession. Saturn is the second largest planet in our solar system, being an incredible 10 times larger than Earth, and yet, as the only planet less dense than water, if you could find a body of water large enough to hold it, Saturn would float. Whilst these stats alone are enough to create a cult following, that's not why the planet is trending. Rather, after a blowout battle with Jupiter, Saturn has just regained its title as Moon King. But on the flip side, it also appears to be losing its iconic rings, and even more shocking, you'll never believe the effect these rings are having on the planet. Let's get into the details. Throughout history, Saturn has often found itself in the spotlight. Since the days of Cassini, Huygens and Galileo, Saturn's bewitching appearance has attracted all who have seen it, astronomers and moons alike. The planet has a diameter of about 116,500 kilometers, 72,400 miles, making it roughly 10 times wider than our planet. It's mainly composed of hydrogen and helium, with trace amounts of other gases. This is why Saturn would theoretically float if it were placed on a body of water. Saturn has a fast rotation period of about 11 hours, which forms its oblate shape, flattening at the poles and bulging at the equator. However, it takes the planet almost 30 Earth years to orbit the Sun one time. One birthday in 30 years? No thank you. Besides rings, Saturn is famous for its many moons. The planet is always in contention with Jupiter for the title of Moon King, but more on that later. Right now, let's take a quick look at Saturn's rings and why they have the scientific community so excited. Saturn has the most complex and largest ring setup in our solar system. Its rings are grouped into 7 distinct zones, from A to G, but they're all composed of similar material, ice and rock. The rings of Saturn span an impressive distance. The main ring system has a width of about 280,000 kilometers, 175,000 miles. The Cassini-Huygens mission orbited Saturn from 2004 to 2017. While the mission provided detailed observation and brilliant images of the rings, it's only now that scientists have been able to uncover the true nature of the rings around Saturn. Using data from the Cassini mission, they've come to 2 new conclusions. Firstly, Saturn's rings are slowly disappearing, and sometime in the future they'll disappear completely. Secondly, after decades of heated debate, we've finally uncovered the true age of Saturn's rings. You're correct if you think a ringless Saturn is not the end of the universe, but the effect of these disintegrating rings, as you're about to see, is pretty astounding. Before the Cassini probe's planned crash in 2017, it plunged into Saturn's atmosphere, where it made some very peculiar findings. One such find was the presence of particle rain. Particle rain is formed when ring particles break away and descend into Saturn's atmosphere. This normally occurs when the rings are blasted by solar UV light, micrometeorites, or solar wind particles. While the particle rain formation process has been established for some time, it's only now that scientists realize that these cascading particles are also responsible for heating the planet's atmosphere. It may sound strange, but this conclusion comes from data meticulously compiled from Cassini, Hubble, and the 2 Voyagers. So, how do icy particles wind up heating the atmosphere? Well, when thousands of ring particles descend into Saturn's atmosphere at once, their extensive collisions with one another create sufficient energy to heat and alter the composition of the atmosphere. This new finding offers exoplanet hunters a new way of analyzing planetary atmospheres and may even help scientists confirm the presence of so-called exo-rings, not even visible with our current telescopes. Even more exciting is the discovery of the age of Saturn's rings. It may surprise you to know that, for decades, the question, how old are Saturn's rings has been a topic of hot debate among cosmologists. And for most of the 20th century, it was assumed that Saturn's rings were as old as the planet itself, about 4.5 billion years. Well, that idea was recently cracked way open when researchers finished thoroughly assessing data from the cosmic dust analyzer that was aboard the Cassini probe. They discovered that not only will Saturn lose its beautiful rings, maybe as soon as 100 million years from now, but also that its rings only developed about 400 million years ago. That may sound like a long time, but in cosmology terms, that's a blink of an eye. And how fortunate are we to live within that blink, where we can witness Saturn's mysterious beauty. Now, let's talk moons. Saturn has a lot of moons. For years it's been in an imaginary battle with Jupiter over who has the most moons, and until recently, Jupiter was in the lead. Now, it's not like both Jupiter and Saturn are actively recruiting an army of satellites. These moons have always been there. It just required advancements in technology for us to actually see them. And right now, with our current tech, Saturn is in the lead again. Thanks to a team of astronomers, Saturn once again sits on a celestial throne of moons. The team discovered 62 new moons orbiting Saturn, putting the planet's total moon count to 145. This rivalry between Jupiter and Saturn has been like a marathon, and 2023 has been one of the highlights of this long-standing race. That's because we've seen the lead change twice already this year. In February, Jupiter had overthrown Saturn as the Moon King when astronomers discovered 12 new moons orbiting the planet. This took Jupiter's total to 95. But with 62 new moons, it looks like Saturn may have just left Jupiter in the proverbial cosmic dust for good. Scientists were able to discover the new moons using a technique known as shift stack. This involves taking several images of a particular spot and aligning them in a single frame. Using the shift stack method, you would spend 27 days keeping your eye on a single spot in the sky. Talk about being the boss of staring contests. Thankfully, NASA's Transiting Exoplanet Survey satellite, TESS, is usually used for stuff like that. Moons that are too faint to be seen in a single image can be observed in stacked images. As you may have guessed, the shift stack technique is often used by astronomers searching for exoplanets orbiting bright stars. However, this is the first time this sort of thing has been focused on Saturn, and bam, 62 moons. Who knows what we'll find if we look even deeper? To be more specific, right now, we've found 62 irregular moons. They're classified as irregular moons because of their weird orbits, which are inclined, eccentric and retrograde. Irregular moons are moons that have been pulled into their parent planet's orbit, unlike regular moons, which form within a planet's orbit. These irregular moons are thought to have formed when larger moons collided and broke apart, approximately 100 million years ago. Again, it may seem like a long time ago, but these rocks orbiting Saturn are mere juveniles from a cosmological perspective. So, why all the excitement over a bunch of moons? The precedent has been set. Previous missions to Saturn have revealed moons with spectacular features and characteristics, unlike anything we've witnessed on our own natural satellite. Saturn's moon Enceladus, for example, seems to have all the key ingredients to support life. There's carbon, hydrogen, nitrogen, ammonia, methane, oxygen, and even phosphorus. Although Enceladus is a very small moon, much smaller than ours, it has garnered so much attention because of the promise it holds. Beneath the moon's water-ice surface, there's believed to be a massive liquid water ocean. We even have photos of Enceladus shooting out icy eruptions from its many cryovolcanoes. Hey, sounds like a future tourist destination, if you ask us. And NASA's Jet Propulsion Lab is on top of it. Engineers are currently finalising plans for a 99-kilogram, 220-pound robotic snake that will slither around Enceladus, searching for life. Expectations are also high for Saturn's largest moon, Titan, which is primarily composed of nitrogen and methane. The abundance of organic compounds puts Titan at the top of NASA's list for scientific exploration. There are already plans to launch a giant dragonfly, as early as 2026, to survey the Moon, looking for building blocks for life, and sometime in the 2030s, researchers are expected to send a submarine to investigate Titan's methane oceans. While Saturn itself cannot support life, do you think one of its moons might? Enceladus, or maybe one of the new moons? Let us know what you think in the comments.